In Unit 9, we're going to be working with polynomials, and for Section 1, I want you to be able to identify, add, and subtract polynomials, and also to classify them. We're going to cross off this graphing part right here, so we don't have to worry about that. Before we get started, there are some vocabulary words that I want to go over. The first one is a monomial. Now, I use the term monomial. That is a number or a product of numbers and variables with whole number exponent, and it's the simplest type of polynomial. So a monomial could be something like 2x squared y. Oops. Now, a polynomial is, a monomial, or a sum or difference of monomials. So basically it could be this, or it could be x squared plus 2x plus 5 or something like that. Now a term, when I use the word term, I'm talking about each individual monomial in the polynomial. So back up to here. This is a term, this is a term, this is a term. Okay, now we also need to talk about degrees. Now the degree of a monomial is the sum of the exponents of the variable. Now that's just for the monomial. We find the degree of a monomial differently than we find the degree of a polynomial. So let's just go down to the bottom here where there's a table asking us for degrees of monomial. So when I look at a monomial, so this is just for the monomials, one term, I add all of the exponents. So this here is 2 plus 7 plus, this has a 1 on it. So if we add all of those together, we're going to end up with 2 plus 7 plus 9, which is 10. And now we have a different monomial here. And remember, when there's not a variable there, it's not 0, it's 1, because anything to the 0 power is 1, so it would take away that variable. So we would add 1 plus 8 plus 7, and that is going to give us 16. So that's for one term. Now the way that we find the degree of polynomials when there's more than one term is different. Let's go back up where our definitions are, or vocabulary. The degree of a polynomial, so this is the degree of the term with the highest degree. So what we're going to do, there can be more than one term in a polynomial. So we're going to look at each individual monomial. We know how to find the degree of a monomial, and then we're going to pick the highest. So let's go down for the examples of polynomials. So what we do is, this is an individual term. And over here we said that the degree would be 2 plus 7 plus 1, and it is. So this is going to have 10, a degree of 10. And we said that this one was going to be 1 plus 8 plus 7, so it would be 16. So I do, whenever there's a plus or minus in between, we have to find the individual term, the degree of the individual term, and then we find the highest degree. So the highest degree would be 16, so that polynomial has a degree of 16. We're going to do the same thing with this one. Add the exponents. 2 plus 9 is 11, and this exponent is just 15. And then 8 plus 8 is 16. So now I choose the highest. So that would be 16 also. So just make sure you're finding the degrees differently between monomials and polynomials. Quite often when I have a quiz or a test, I always have students, or a few students, who will just add all of these up together. And that's not what you do. The monomials are individual. Find their degrees first. Or each term, you can each term you can think of as a monomial. So find their degree first, individually, and then choose the highest one. Okay, so that's how you find the degrees. Now we need to figure out when we have a polynomial. So if you check this list, today you're going to be asked if you the question that you're given is a polynomial. And what you need to check is that the polynomial has no variables in its denominator. So something like you couldn't have would be 1 over x. That's an example of having a variable in the denominator. Also, no variables in the exponents. So 2 to the x is not a polynomial. We'll just put not up here so we know. The other thing is, or another thing, is you cannot have variables under the root or the radical sign. So if you have something like the square root of x, that is not a polynomial. You can have no variables that have absolute value signs around them. So that would not be a polynomial. And you can probably guess what goes in the next blank. All variables have whole number exponents. Now remember from earlier in the year we went over whole numbers, so we could use the terminology throughout the year and we wouldn't have to redefine it. Whole numbers start with 0, so 0, 1, 2, 3, ... for their exponents. So if I have, so that means no decimals in the fractions, or no decimals, no fractions in the exponent. So something like 2 to the 1/2 would not, or 2x, let's make it, squeeze an x in there. 2x to the 1/2 would not be a polynomial. So on your worksheet today, what you're going to look at to determine if you have a polynomial, look at all of the variables. That's all you have to check for. And if your variables don't have any of this stuff here and have whole number exponents, then you know that you have a polynomial. So let's look at a couple of examples here. These are all polynomials. I'm looking at my variable, and this one's not in the denominator. The variable's not in the exponent for either one of these. It's not under a square root sign, it's not under absolute value signs, and it's whole number. It has whole number exponents. Same is true for this one. Now, someone asked me about this one. They said, I thought you can't have decimals. You can't have decimals in the exponent of a variable, but you can have decimals in front of the variable. All right, now let's go over why these are not polynomials. We're going to circle the reasons not. This, looking at the variable, it's in the exponent. Looking in the variable, it's in the denominator. Looking at the variable, it's under the square root. Looking at the variable, it has a decimal exponent. Looking at the variable, it's inside the absolute value. So for those reasons, these are not polynomials. All right, now the other thing that we need to do is we need to put polynomials in standard form, and we did this with quadratics, and we did it when we were using the quadratic formula. It had to be in standard form. So a polynomial with one variable in standard form is when its terms are written in decreasing order by degree. That means the degree of the first term of the polynomial in standard form indicates the degree of the polynomial. And the leading coefficient is the coefficient of the first term. So we get a lot of information from that first term. So looking here, you can see the degree. We talked the exponents, if there's just one of them on here. This is the degree of the polynomial. So it goes 3, 2, 1, and 0. And then the leading coefficient, if you're in standard form, the leading coefficient is always going to be the first term. And the degree, if you are in standard form, will always be found also in the first term. All right, now, we also need to classify, which means we're going to name them. A polynomial can be classified by its degree and its number of terms. So you want to think of a polynomial as having a first and a last name. its first name indicates the degree of the polynomial, and its last name indicates the number of terms in the polynomial. So this is going to be your first name. This is going to be your last name. So if you have a degree of 0, this is an example of a degree of 0. There's no variable with it. And the reason why is if you have x to the 0 power, anything to the 0 power just changes to 1. If we have a degree of 1, it's called linear, so that's looks like this. And degree of 2 would be quadratic, and degree 3 would be cubic. Degree 4 is quartic. You can think of quarters. There are 4 quarters in a dollar. Most people don't have a problem with cubed, x cubed. And quintic, you can kind of think of quintuplets. So the first part of that indicates that you have a degree of 5. So quintic could look like this. Again, the degree of 5, and then, you don't have to have all these terms. You may have some of them missing, but when you are in standard form, you look at the first term, and the exponent will give you the degree. So we only have specific names up to 5. If a polynomial has a degree 6, you refer to it as a 6th degree polynomial. And the same is true for polynomials with degrees that are higher than 6. So that's the first name. The way that we indicate its last name is the number of terms. And so if it has 1 term, think of a prefix that means 1. Monomial, M-O-N-O-M-I-A-L. If it has 2, we usually use the word or the prefix bi, so binomial. 3 means tri. 4 or more means you just say, we don't have a specific name, but you still have to indicate in the last name how many terms the polynomial has. So it's a polynomial with 4 terms. So again, when naming, use a first and a last name. Oops, I need to slide this over here. First and a last name. All right, last thing we need to go over would be adding and subtracting polynomials, and they need to be placed in standard form. So when we add, we just line up like terms. This is an x squared. I'm going to put an x squared under here. This is an x cubed. So as I'm in standard form, I want to put them the highest exponent first. So I'm just going to slide this over here. 16x cubed plus 6x squared takes care of that one, and then we have a minus 5 here. So we're going to add, that's going to be 16x cubed, and when I add these two together, I'm going to get a minus 30x squared, and then a plus 6x, and we add these together, we get minus 16. Now, I always tell you to be careful about subtraction. Always think that you have like a negative 1 out here that has to be distributed to all 3 terms. So let's go ahead and do that first. That's going to give us negative 15x squared minus 3x plus 2. So I took the opposite of this one, opposite of this one, opposite of this one. Now, this is not in standard form. So we want to line up our terms, but we want them to be in standard form first. So I have a 5x cubed plus 6x squared. I don't have an x to the first power, so I'm going to leave a little space right here. And then I have a plus 12. Now I'm going to take this polynomial and I'm going to line it up underneath this one. So it's going to be minus 15x squared minus 3x and then a plus 2. Okay, so when I add these together, I get 5x cubed and then minus 9x squared minus 3x and plus 14. So when you're adding, just line up the like terms, and you only add the coefficients here. You don't add the exponents. And then if you are subtracting, you think of, distributing a negative 1 through all of the terms in the second polynomial, and then you can just line them up and add, and they need to be in standard form, so highest exponent in decreasing order.